I need 4, that gets me to 4, and that stays 1. The other thing is that the if you can divide all the numbers by the same number, then you've got too big a number. So um, you just can't go up as high as you want.
Right. And then I was taught the table way, and I think that is a little bit like simpler for me. Could we possibly do it that way?
Say that one more time.
Can we possibly do it the table way? Because that's how I was taught. And I
I have
just
no
like I find you don't know how to
I
do
don't have
it.
any way to help you using the table way because I don't know what that is and I don't know. So I won't be able to help you with that.
Or okay. Um because I would like to do it that way.
So I
Then
can
I
look.
guess we
I
can.
I can look, but let me you may consider one of the reasons you're getting tutoring is to get a different approach to doing these problems. Uh, but it's not for me to convince you one way or the other. It's just for me to recommend that we don't uh, necessarily do it a way that could be more difficult than just using rules. It's essentially just a list of rules to go through.
Okay.
Uh, but
Then can
I'm
we
look
try?
I'm looking it up now. I mean, I'm looking it up
Okay.
and um actually go to the images, probably be faster. Okay, so let's try what I think you mean by the table approach here, and we'll see if we're in agreement.
It's like
Uh,
reactions to what was it? It was reactions to
so it's reactants, which is very important. The terminology is very distinct, and then product.
yeah, reactions to the product. So then you do like how many reactions
You,
there
you
are?
keep saying reactions though. It's reactant, and it's important
Reactants.
because it's a different altogether, and your instructor may care when you go take a test. So we can
Right.
do that for this next one here. Uh, okay, so we'll start out with NaHCO NaHCNaCO. So I think that's everything. And then NaHCNO, Na. Okay. So
Mhm.
first thing is to count them as is. You got one Na, one H, one C, and 3 O's. And then currently you have 2 NAs on the right, 2 Cs. This is why I don't like this approach because it doesn't make it clear that they're separated. O's, you got 3 here, 4 here, 6 there. And then your 8, you got two H's.
Right. So then you need to multiply it to by the one to get two H's on the reactant sides.
That's right. That's right. So
Right.
there's no issue because there's only one place to put that. So if you put a 2 here, all of these go to 2, and then the last one goes to 6, and you have your answer.
Okay.
All right, so let's do one more decomposition before we switch to single replacement.
All right.
All right, so the just like we got before, we got BB, we got N, we got O, BB, N, and O. All right, why don't you tell me how many you have on the left of each of these?
So we have one lead, one nitrogen, and three oxygen.
So this 2 applies
Or
inside here.
wait,
It's 2 times
six.
3 is 6, and then there's really a 1 there. 2 times 1 is 2. So there are 2 and
Right.
6. On the right, you've got 1 lead, 3 O's, and 1 N. And you can see the multiplier is 2 on the right though.
Mhm.
So I'm sorry. No, 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 that's not right. So this is where we run into problems. Like you see to go to end, you gotta go by two,
Mm-hmm.
right? Um, so that means you gotta do something over here. But the thing is, the lead can't change, right?
Right.
So this is where my approach would be you're noticing that whatever goes in these two positions is the same,
Okay.
but
Yeah.
you're using this table method, so you know to double up the end. So I guess you got to put a two
Mhm.
there, which gets this becomes two, and this becomes now four, which means that we can't change n, we can only change the o. Well, if you put a two there, that gets you
Wait,
an
why would it become four? I thought it would become six because you're multiplying two and three.
this is the limitation of this table method. The two, it only works the way you're talking about if you're changing the number over here, because that will double or triple everything. Notice O is in three places.
Right.
So you're right. You could, I mean, and maybe that's the way you guys are doing. I mean, you could put a two in all those places, and that'll give you potentially more than what you want. It'll give you two, two, that's four, and then four here, that gives you eight,
Okay. Word. And
which,
then can we try your method after this also just to
well,
see?
yeah, so that's where it's where you got to focus in on like what is actually, because it's not that it's three, it's really that
Mm-hmm.
it's, or I'm sorry, did I put three? No, there four to start. Sorry,
Mm-hmm.
four to start. Um, your problem here is that, well, it's really one, one, and two. So to get to six, if you double the n, you have to then double one of these. Well, which one do you double? It makes most sense to double the middle one
Right.
because and then what most students do is they know to recalculate each like as you go. There's like, okay, so now I've got that's two, so now this is six. I got that, that's now two, so I'm in good shape.
Right. Okay. No, I'm confused.
Right. So the table method only works when the way that they're showing it only works when you can always double, like one becomes the other. And maybe on the easy ones it does,
Okay.
but not on all of it. That's okay.
Right.
We'll go
All
to single
right.
replacement and maybe we'll find that it works out.
Okay. And then how do you do it like your way wise with like this equation?
Well, it depends on the problem.
Okay.
Depends on the problem. So like one of the things I notice here is that H appears here and here. So I know that like I've got to balance the H's. I think the table method helps, but
Hmm.
you sort of have to pair it with a bunch of other rules. Same with the zinc.
Right.
So whatever goes in front of zinc is also going to go here because those have to exactly match.
Okay.
Okay. So
Hmm.
it's kind of like we're going to use both approaches just to kind of like make it a little bit of a hybrid, but you got one, one, and one. And then on the right here, you got one zinc, two H's, and two Cl's. Okay, so now like we know that we've got to multiply this Cl by two and this H by two. So if you
Hmm.
put a two there, well now we've got it matched. So like it kind
Right.
of works. It kind of works, but you have to be willing to like also adapt and apply some other rules there.
And like what other rules are you talking about?
Well, so far you're just looking for like where like the same letter appears, and if they're the same like I don't know what to call this other number, but um, you're just looking to see um, if something is the same or different. I'm sure
Right.
more of them will
Okay.
come up here. We'll uh we'll look at a few more of these.
Okay.
Okay, so this one's got more going on. Like one of the things I noticed is that PB and PB are here, and
Mm-hmm.
they're the same. Like I don't know what to call this number underneath, but because they're the same, you know that whatever goes in front of PB is also going to go in front of here. Same with AU. Whatever goes in front of AU is also going to go here. So you kind of know that these are going to match and that these are going to match.
Okay.
And that helps you when you change some numbers.
Right.
And NOs. Okay, so on the left here, tell me how many PBs you have, AUs, Ns, and NOs, please.
So there is one PB, one AU, three nitrogen, and nine oxygen.
Good, good. And maybe that'll give us some insight into what to do
Right.
over here. So we got one, we got two, and we got 6 and 1.
Mm-hmm.
Okay. And so we know that these we need to get more of these over here, right?
Mm-hmm.
But you can't go from 6 to 9. But
Yeah.
if we were to double all of them on the right, so well, I'd be careful here. But if we go to so let's deal with the O. That's the most complicated one at the moment. So if
Okay.
this goes to 18, to get the O over here to 18, you have to multiply by 3, which is
Right.
means putting a 3 in front of this. And so like now it's like, well, how does that change everything? And then 2 here
Mm-hmm.
gets you to the 18 there. So now that we've got these two balanced, we know from these arrows that these are also going to be the same. So it
Okay.
tells us what goes in the other ones. Now to
Okay.
check, we'll just recount. So now there are 3 leads, 3 leads, 2 AUs, 2 AUs. Nitrogen has 6 on the left. On the right, it's got the 3 times the 3. No, 2 times 3, you got 6. There we go. So it does work.
Okay.
And this is kind of the this thing. So now, another weakness that I'm going to have, my ability to help in chemistry is mostly limited to the math problems, and there are a number of them.
Okay.
Like eventually you get like uh, limiting reactants and products stuff like that. Like
Mm-hmm.
this is a single replacement, so I know that like the Mg combines with the NO3,
Right.
but I don't know how many. You know,
Okay.
I mean, like I have to go look up the charge of Mg, the charge of NO3. Now, the wonderful internet will help you figure out the reactants
Right.
and the products. But like in terms of like how I can help you, I mean, I'm going to a periodic table basically. I'm not. Um,
Right.
so if you want us to write the equations, I'm just going to have to look them up. And I know that that is kind of a lot of this. So,
Okay.
like for example, what's the charge on NO3? Do you know?
Oh my gosh. No, I don't know.
Okay. So it's -1. So NO3 is -1. So this one right here is -2 because there's 2 of them. That means copper is +2. Mg, the charge in Mg, I don't know what its charge is. I have to look at the periodic table. Its charge is, let me just double check. Yeah, it's a +2. So you're going to need 2 of them there to go with the Mg.
Mm-hmm.
And then copper is fine by itself. Okay, so now you got to put the is that okay so far?
Yeah.
Okay.
Yeah.
So like Mg is in the second column. That's how I got its charge. Copper, I had to get it based on NO3 because these end up balancing. NO3 is -1, but you double it up. Now, in terms of balancing, it's the same as before. You just make a table or you like recognize, okay, these have to be the same,
Mm-hmm.
and then the copper has to be the same. These end up all being one. I don't know if you have your solutions, but
They're all okay. Mm. And to these, are we like trying to find what it equals?
I'm sorry, what are you asking, how we found these or how?
Yeah, I guess like how did we put it together?
Well, the fact that there's only MG and MG in one place, I know it's the same number. And so you just start out with one and you literally just look. Now, if you make the table, you will see that it's the same numbers in both places. One MG, one CU, two N's and six O's. And then on the right, it's the same as well.
Okay.
But that's all assume that this is the correct balancing. Like, here's the thing, it may be that copper is really copper two here. I don't know. That's where I'm limited by this. So when I help students, I usually say the same thing I said to you, but I also go out to the internet and double check the the reaction. Like
Right.
you can Google search the reactants to produce what do they produce, and yeah, you end up getting a something.
Okay.
All right. Should we do another one
Yeah, let's do one
of these,
more
or do you want us
along
to move
this.
on to the other side?
Let's do one more and then move on to the other side.
Okay. All right.
And then this is where like I need to know if there is I don't even like the exponents at the bottom. Like I need to know their charges.
Yeah. So H is plus one, CL is minus one. H is in
Okay.
the first column, CL is in the seventh column.
All right, and then are these for, because I know most of the elements on the periodic table don't have like for sure charges. There's only a few, so I guess is it only the ones that have the actual charges that are in the equations, or are there going to be some that I don't know the charges and that like I'm going to have to figure them out?
Yeah, great question because like most students have the same question. You can see there's sort of like the variable charges are in the middle here. If they're in the first column, the second column, or what's called the third, the fourth, fifth, sixth, seventh, these are all well known. Okay, it's only these in the middle. So like Fe, iron's a common one. What you'll see is it'll say iron 2 oxide or something, and then you know it's
Yeah,
plus 2. But it might say iron, and they use Roman numerals, don't know why, but that's what they use.
yeah. I don't know why those always mess me up too. I'm
Yeah,
still trying to figure out how to even figure out like
but
ones that
that's
aren't obvious.
but that's telling you the charge. So if you get an FeCl2, you know that Ce is minus 1, so the net charge is minus 2, which means Fe is plus 2. But you could also get an Fe, I don't know, Fe, I guess Cl3, and then you know it's minus 1, which means it's minus 3, so this is now plus 3. Does that uh, does that make sense? How you know?
Yeah, yes, no, not really, because like I don't know my charges.
It's all from this picture. I mean, this is the best picture I could find. I would buy one of those really fancy periodic tables that they sell, like the yeah, they probably sell them in your bookstore on Amazon or and bring it into class. See if you can use the one that's got maximum information on it. like
I'll
this.
probably just upload this one to like my computer. Maybe I can use it on my test or something.
Okay.
But yeah,
So I mean,
okay.
this is it. You just got to figure out where it is, which column it's in, and
Right.
that'll tell you the charge. And the ones in the
And
middle are all
then
good.
yeah, I was just gonna ask like the ones in the middle, how do you figure those out again?
You have to be told. There's no way to
I just
know.
have to be told.
Yeah.
Okay.
Or you have to use something else to figure it out. Like the fact that O is 2 minus. So if it's AUO,
Mhm.
then AUO is O is minus 2, so AU must be plus 2 because the net charge is 0 on these.
Okay. Wait, I want to try it. So it's basically the opposite if it doesn't have a charge. Yeah. So like since O is -2, AU would be +2.
Exactly.
Oh, okay. That's not that hard. Okay, cool. Okay.
Okay. Um, let's let's go back to this one here. Restart this. So CL is -1, H is +1, so you know that you know what its charge is. Um, so now when you pair AL with CL, AL with CL, AL is +3. Yeah, AL is
Yeah,
+3,
+1.
which means that you need 3 CLs to go with it. Plus,
Okay.
now 8 doesn't appear on its own, it's 8 2. I don't know how you know that either. That's just a known thing in chemistry, I guess.
Mm.
These are good questions to ask your instructor. Like, how am I supposed to know this? And if
Yeah.
this were a math class, I could tell you why, because I don't know or like chemistry. I don't know why. I just know how to do.
Okay.
So now you're down to doing the same thing, building your table. You got one AL, one H, one CL, and you've
And it would
got
just be one, right? Because they're already balanced. Or is there
well, you
more?
got you got 3 CLs and 2 H's this time. So definitely got some issues here.
Oh
Um,
yeah, I did.
but it you know that these two are going to match and that these two are going, well, no, sorry. The first the first one and the first one match because of the AL. That's for sure.
Mm,
Okay. And then what that means is like if you and that's where there's kind of this guess and check approach. You're like, okay, well, I got 3 here, so I need to get 3 CLs here. So I put a 3 here. That gives me, 3 H's, which is no good because I got 2 here,
right.
right? So it's what's called an iterative approach. If you double this to get 6 CLs to put 6 here,
Mm,
okay. Now uh you've got 2 and 6, and then on the left here you got 6 and 6, but your H's don't match and your ALs don't match. So now
mm,
this matches with the ALs, putting a 2 on the left. And then to get your H's up, you can put a 3 here, and that'll get you to the 6.
right. Okay.
So it's a combination of a table and just being reasonable
And
with
just like right. Okay.
okay. So D exercise D's and E's, they're gonna have a lot more challenge because they all have to be
Mm,
written out. So double replacement
mm,
means that you're gonna pair like DA with PO4 and Na3 with Cl2. But you should figure out the charges first before you do this. So we talked about
okay.
the idea that Cl is -1, so that's -2. That means Ba is +2. Na is what, +1, so Na is +1. So that means this is +3. That means PO4 is -3. to balance it out. So now when you combine them, when you combine BA with PO4, we know that BA is +2, PO4 is -3. We need 3 BAs to get to +6, 2 PO4s to get to -6. Is that okay or clear? Maybe.
Um, can you explain to me why there's a six? Why there's sixes now?
So when you double the number of the, I don't know what the right word is. It's not as a compound. I don't know. When you double this, you double the charge. So it's originally -3. PO4 is -3. So you should have been given a table of polyatomic ions. It's like a reference sheet. Did you get one of those?
Yeah, it's with all like the formulas and stuff, right? That
Yeah.
look
And
like
then
this.
you're
Yeah.
supposed to remember all the, nitrate, nitride,
Yeah.
potide. I don't know them all, but so yeah, there's a bunch of these.
Hmm.
Phosphate, falsified. There's all these ones.
Hmm.
And the charges are more important. But some teachers emphasize like how to write them and things like that. But when you have two of them, it's doubling the charge. So it was -3, doubling -3 gets you to -6. You're trying to match the +6 and the -6 like that to get back to 0. All right, so then the other one we're combining here is Na3, or I'm sorry, Na, not Na3, Na with Cl. And we know that Na is +1, Cl is -1, so that's your table salt, sodium chloride. So now we make the table Ba, Cl, Na, P, and O. 1, 2, 3, 1, 4. On the right, we've got 3 Bas, 2 Ps, 8 Os, 1 Na, 1 Cl. So the thing that's different about this one is there's no matching for sure. Like there's no like they both have a BA to the one. You got a 3 there.
Hmm.
They don't have a CL to the 1 or the 2.
Right.
Okay.
So then you have to multiply the BA on the right for to get three. But then you'd have to multiply chloride on the left, or I mean on the right to be two. And
So
then
like
barium on
the,
the left to be three.
yeah, so this time you know that like the number here in front, like you just said, 3 has to be a multiple of this. Like whatever you put here, like if there's a 1 there in front of the BA3, it's a multiple of 3
Mm-hmm.
there.
Right.
Okay. So what does that do? Well, it pushes that to 3, and then Cl goes to 6, which means that you're going to need a 6 over here. So
So
that's
then you
6.
multiply that by six. Yeah.
And then to get this one to 6, you got to multiply by 2. But that gives you 2 Ps and 8 Os. And does that match?
Yeah.
It
Yeah, it
does.
matches.
Excellent. Excellent.
But
Okay.
then I'm confused because with the sixes, do you just include them or something? Or
Sixes match. When you say you're confused, I mean, we
right. Oh, you put it at the end. I didn't see that.
it's like a back and forth until you get it.
Right. Okay.
And in the balancing, 'Cause balancing is easy if you have the right equation. If you write the wrong equation, you can there's sometimes you can get it where you never balances. So you can be really in bad shape. If you're not paying attention to that. So anyway, that's just a side comment there. All right, do you want to do another one of these?
Um, I honestly kind of want to move on to my chapter 7 homework. It's moles, it's more equations.
Okay,
I think
sounds
that
good.
would be, yeah.
Sure. Do you want to share your
I'll pull
screen? Do
that
you want
up.
to send over
Yeah.
snips? What? Okay.
I'll just
I'll
share
ma
my screen and then you can snip it if you want.
All right, so you're now co-host. You share your screen.
All right. Let me emoji it. Hmm.
I am not seeing your screen if you're sharing.
Oh, you see? Mm, there we go.
Right. Great. Yeah, let me grab some of these here. You can also, in the future, you can always download this and drop it into an email. Well, let me grab a snip
Okay.
and of this, and we'll get through as much as we can in the time we've got left. Yeah, I mean these are more mathy. These are gonna
Yeah.
be things that
And it's funny because I'm bad at math, but like I understand this better than like the actual chemistry that we're doing.
well, all right. So I've got it. I'm gonna share my screen and we'll get back to it. You definitely need a periodic table for this, but I'll show you some workarounds for it as well.
I'll pull up the one that I took a picture of that you had up.
All right. So the MM is the molar mass,
Right.
and so it's this is very much from the periodic table. So you need the molar mass of carbon. You need the molar mass of um, hydrogen and oxygen. So the way to do it is to get those values, but you need to know how many. So you've got 7 carbons, you've
Okay.
got 6 hydrogens, and 2 oxygens. Is that clear?
Yeah.
You don't care that the order they're in. This means something to a chemist. It means nothing to me. The
Right.
Then you need the molar mass of each. So if you look at your table, 12.01, hydrogen's 1.01, oxygen is, you might even see 15.99 on your table. Like for me, because I don't do this stuff, I'm okay like rounding to this, but you
Okay.
really want to check with your instructor to see if that's okay. But
I
it's
so I remember that we multiplied by what did we multiply? We multiplied the mass by I think how many carbons and hydrogens and oxygens, and then we added it all up to get the molar mass.
That's right. That's right.
Yeah.
And what I'm referring to is like these little tenths here don't really matter, or hundredths,
Right.
but some
I
instructors are
want to
really
say to my
picky.
teacher, I want to say to my teacher, it does. So
Good.
I'm probably gonna choose to keep those.
Right. And so they probably have specified a table that they want you to use, kind of a
Right.
standard one, but this is
Um,
122.11 grams. I'm sorry, I missed. Why did I? There's sorry, there's Okay, I messed this up here. Yeah, that's right. Any questions that
Um,
before we move on to part B?
I hold on, let me maybe my math is wrong. Give me 1 second. Is car? I thought. Wait, is hydrogen 1.001 or is it 1.01?
Depends on what you're looking at. I got it as
Right.
1.01.
Okay.
You're gonna if we're different, we're gonna be different in like the hundredths place.
Mhm.
Not a big deal.
So I got 117.06, but I had my decimals at the end also.
That is far enough off that you would get marked off. This is truly the correct answer, verified by a molar mass calculator on the internet. Um, yeah, this is 84, 6, and 32. So just double check
Mm.
um, that. Let me know when we move on to B.
All right, I'm ready.
Okay. So the same thing here. We're gonna make a little table. That's this is where I do agree. Let's make a table. There's four Ks, one Fe, one iron. There are six Cs, and there are six Ns. All right. So you go to your periodic table and you want to look each of these up. It's nice when you start reusing them because then you start to remember some of them, which really helps. It's very tedious to and you're gonna do this over and over again. Like in future problems, they're just gonna expect you to know how to do this, and
Right.
you've got to get as fast as you can.
I'm gonna pull up my periodic table for
Yeah.
just 1 second.
All right. So the like K, I have it at 39.1. Fe is 55.84. C 12.01. N is 14.01. It's kind of a table. It's kind of like quantity, weight, total.
368.30.
Good. Okay. Any questions on that before we move on to
What would the
another one?
units be? What would the
Grams,
units be?
grams, grams.
Would it be grams in molar mass, or would it just
Nope.
be grams?
Well, it's grams per mole.
Grams per
But
mole.
it's kind of assumed that you're asking about it in 1 mole. So I think it's like this is the official answer, but it's like when someone asks you how many grams are in 1 mole, you say that's as many grams. What is the molar
Right.
mass? It's grams per mole.
What is a mole exactly? Like, is that just how many atoms are in, or like how many particles are in the atoms?
Well, let me ask you a related question. What is 1 dozen?
12.
Why? Why is it 12 and not 15?
I couldn't answer that
Okay.
because
Why is it called the North Pole and not the South Pole? Why are lights on
called
versus off,
light
right?
because
So th
it's just, yeah,
it's just the way it is, right?
right.
A mole is a collection of things. It's a large collection.
Okay.
So you're right. You start talking about Avogadro's number, and that's relevant to this next problem here, problems. Sorry, I'm just trying to get this up here. Where did it all go? Okay. So let's see if we can get 1 or 2 more in here. Um, let's do the more standard one. Part B. We'll just do two. We'll do them in order. 2A. Okay, how many moles are contained in the following? So you're starting out with 4.5 times 10 to the 22 atoms of copper. So there are 6.022 times 10 to the 23 atoms in 1 mole. Doesn't matter what it is. Like just like the dozen. Doesn't matter if it's a dozen bananas, a dozen grapes. A dozen is a dozen.
Right.
Okay, so here these just cancel out. Biggest issue in doing these problems is remembering to put, this stuff in the numerator and denominator in parentheses.
Hmm.
That way, when you calculate it, it actually works out.
Question, how did we get 10? Oh, wait, never mind. I thought that was 33.
Michael
Never
Jordan's
mind.
number, if you're a sports person, that's how I remembered it. A lot of other ways, I don't know.
That's a good way to remember it.
Yeah.
And then you would
And
just divide that.
yes. Yep. Yep. Make sure you get the
And
same number.
then,
Any questions on that? Thoughts?
I'm still setting up.
Okay.
I I got 0.7472, a big number, so it would technically be 0.75, but I didn't get like zero in front of it.
Check that you don't have like a 10 to the -1 at the end. This is for sure correct. 1000% sure.
I did use parentheses. Oh, I did 10 to the 23rd, not to the 22nd. That's why.
Let's really quickly do this last one because we're going to run out of time here.
Okay.
So 0.684 grams of MgCl. You do the same thing that we did for molar mass, which I'll do for you really quickly here because I've got a calculator that does it. But your MgCl2 ends up being 95.21 grams. So you start out with the given quantity. and there are 95.21 grams in 1 mole. And you can see that the grams cancel with the grams.
Mhm.
And so these divide 0.684 divided by 95.21. Oh boy, that's not going to work. 0.21. There you go. So this ends up being 0.0072 volts. And this is the calculation you're going to be doing a lot of in this course. You're going to be converting grams to moles, grams to moles, grams to moles, grams to moles.
That's not bad, honestly. Like, this is simpler than the polyanemic anions and compounds and that bullshit.
Oh. Okay, well, unfortunately, we do have to stop here for today. I
Okay.
know we're getting right into the